Assalamualaikum warahmatullahi wabarakatuh. So we are from HB2 group tutorial, and today we are going to explain what keeps the water in the pail. Okay, so this is an example of the centripetal circular motion in vertical plane. The water stays in the bucket because of inertia, and the water wants to fly off from the circles, but the bucket gets in the way and keeps it in place. So this is the same effect you feel when you go around a tight corner in the car and get switched against the door. So we are going to explain in details about the fundamental why the water in the pail still remain in the pail even though it goes around the circle. So let's move on.
Okay, next I will explain about when the pail is at the position at the top. So basically at the top means at the maximum point. So first I will explain about the equation first. Equation that we can use here at this position is the summation of F is equal to m a AC, which is centripetal acceleration. So we can find the summation of F is tension plus gravitational force equals to the MAC, which is the centripetal force. And at the top position, which is at the max point, the tension is the lowest. So this causes the gravitational to become higher than the tension. So for the explanation, water want to fly in straight line due to inertia, which is to the side. But the water stays in the pail because the pail is holding the water from doing so because the pail is attached to the rope. Thus, the pail forces the water to move in the same direction as it moves, which is in circular motion. The water stays in the pail also because of the normal force acting on the water in the pail, which keeps it from going down and out of the pail. So that is why water stay in the pail at the top position. Next.
Okay, so when the pail at the bottom, Fx is equal to 0 because there is no acceleration at x component. So we just use the Fy. Fy equal to MAC, centripetal acceleration. And we know that tension is upward and the gravitational force is the opposite. So tension minus mg is equal to ma, and ma is equal to mv square per r. So tension is equal to mv square per r plus mg.
From the formula, it can be clearly seen that tension is greater than gravitational force. According to this formula, tension is equal to Fg, which is mass times gravitational force, plus centripetal force, which is mv squared over r. According to this formula, it's shown that because tension is greater than gravitational force, the water would stay in the pail.
Next, at the side, which is 90 degree. So for the Fx is equal to MAC. So Fx is equal to tension and MAC equal to mv square over r. And for y component, there is no y component because it is moving sideways only. So the Fy is equal to 0.
So from the formula, the tension is equal to the centripetal force, and the centripetal force also is equal to the centrifugal force. So what is the centrifugal force? The centrifugal force is the force that acts on the opposite direction from the centripetal force. So the water stays in its position.
Okay, next, if the pail is at any point, we can write the equations. Okay, first, we need to write F equal to MA. A in here, we must know that it is actually the centripetal acceleration. So, next is tension force minus with gravitational force cos theta equal to MA. So, if we rewrite back the equation, we will get tension force equal to Fg cos theta plus with m v power of 2 divided with r. So explanations if the pail is at any point. First, the pail is attached to the rope. Second, it is being held by tension force. And lastly, the gravity acts downward all the time.
So for conclusion, we can conclude that the centripetal force acting on the volume of water to keep it moving in circular motion is greater than the force of gravity which tries to bring the water down. So that's all from us. Thank you.